Broadcasters migrating from SDI to IP. The test and measurement challenges and solutions from Leader. My name is Kevin Salvage. I'm the Sales Engineering and Technical Marketing Manager for Leader Electronics of Europe, based in London in the UK, and I can be contacted on email and mobile, and also via LinkedIn. The numbers and links displayed on screen. So IP sounds great. So how difficult can it be? Test and measurement challenges and solutions from Leader. Moving from SDI to SMPTE 2110 isn't a small leap. It's a fundamental infrastructure and workflow shift. And here's a breakdown of the top 10 challenges broadcasters typically face when making that migration. Number 1, network design and bandwidth requirements. Number 2, precision timing, PTP. We have a new reference source. Number 3, multicast management. It's a way that IP networks handle streams. IP interoperability between vendors. Number 5, new skill sets and training for both operational, production, and engineering staff. Number 6, networking resilience and redundancy. Number 7, cost and budget management. Number 8, legacy equipment integration. And number 9, content security. And number 10, monitoring and troubleshooting these new IP facilities. So number 1, network design and bandwidth requirements. SDI is point-to-point, but 2110 is IP based, requiring high capacity, low latency networking infrastructure. We're all familiar with BNC cables, and a single BNC cable can support a 1080p 60 signal in half duplex. Whereas in IP, an optical fiber connection can go up to 100 gigabits, which could be up to 75 1080p 60 signals in full duplex. SDI content arrives continuously. It's synchronous, deterministic, and well behaved. And it's really good from going from point A to point B. IP, on the other hand, content arrives in packets, and packets arrive when packets arrive. So this is okay for email, files, etc., but challenging for live TV production. So, what are the fundamental differences between SDI and IP? SDI content arrives continuously. We have traffic flows that are constant. We're all familiar with 1.5 gigabits per second SDI and 3 gig SDI. And if you're working with UHD, that could be 6 gig or 12 gig. So we only need to worry about the quality of the road. And that's going to be the cables, the connectors, and the distance between the sender and the receiver. And typically tools like iPattern and jitter measurement are used to monitor the health of the system and the signals within it. But as we mentioned, IP content arrives in packets, and packets arrive when packets arrive. Now, the great thing with IP networks is that we know the quality of the road is good because we've designed the system for 10 gig, 25 gig, maybe even 100 gig wide. What we now need to worry about is traffic congestion because of the way these packets arrive outside of our control. So if we look at SDI and we have a single pixel, that maybe is dropped or we have an issue with, that's going to be virtually impossible to see in a picture. However, the same IP error will result in dropped packets, and that can result in a quarter of a line of video offset. It can be very obvious. So you're going to see how unforgiving IP infrastructure is when it comes to real-time live video. Number 2, precision timing, PTP, SMPTE 2059. SDI has embedded timing via its serial data stream. And many of you will be familiar with the sync pulse that we've grown up with and we view on waveform monitors. In SMPTE 2110, PTP, Precision Timing Protocol, replaces SDI's timing and requires strict, reliable clock distribution. Configuring and maintaining PTP domains across a large network is complex and absolutely mission critical. Multicast management. SMPTE 2110 heavily uses multicast traffic via IGMP protocols for efficient signal distribution. Proper multicast routing, IGMP snooping, and bandwidth controls are essential to prevent packet flooding and maintaining predictable, reliable operation. We've never had to deal with this in the world of SDI video. Interoperability between vendors. Unlike SDI, which has been a universal standard and is pretty much plug and play, SMPTE 2110 systems are multi-vendor IP environments, and each vendor has taken those SMPTE standards and interpreted them. Now, the majority have interpreted them the same, but occasionally you can see certain anomalies within that interpretation, which can result in incompatibilities. And that's where LEADER, as a test and measurement manufacturer, frequently gets involved to identify whether it's the sender or the receiver, or maybe both, that have misinterpreted the standards. And ensuring these devices work, we're now moving to a new control system. So we need to basically have a way of seeing what's on the network, understanding what its capabilities are, and then controlling the signals between those. Unfortunately, AMWA with NMOS has already done this. So we have specifications with ISO 4 and ISO 5 for discovery and registration, and ISO 6 for control. So making these new IP systems very user-friendly and simple and intuitive to operate, like we're familiar with SDI video. Unfortunately, the industry, with the help of the JTNM, has carried out a large number of interoperability testing sessions, and the last of these was at Riedel in Wuppertal back in August 2020. And any product that has passed this testing will carry these certification markings for SMPTE 2110 and also NMOS. And as you can see, there were over 100 participants at the last event, with 105 products and 135 pieces of equipment, including test and measurement. So it's one of the most comprehensive IP test systems that's ever been built. And fortunately, the Fabrics QXL is listed as a reference device. So the great thing with this interoperability testing is that all the results are published. Therefore, you can go to the JTNM's website, you can download the results, and you can check how your favorite vendor for a certain operation, how their tools performed. So therefore, you can select them with confidence that they will interoperate with other systems as you build these new IP networks. 5. New skill sets and training. Moving from SDI to IP transforms the role of a broadcast engineer. In the past, we'd understand picture, waveform, vector, and as I mentioned, for that quality of the road, we'd have tools like the eye pattern and jitter measurement. And within the status display, we'd be looking at CRC errors, EDH in the audio, and for freezes in the black and luminance levels. Now, we require a deeper networking knowledge. So we're going to need to understand VLANs, IP routing, PTP, quality of service, multicast, etc. And with that comes a whole new set of tools that not just display this information, but also put it in a graphical format so you can see it against time. And on the leader products, these graphs can be exported so that they can be analyzed to find out exactly why an issue occurred. And with the customizable layout, you can actually align the various graphs so that you can see the same time. So if something happens on the network or something happens with PTP, you can see how that maybe has affected your timing chart and so on. Reskilling operational teams and engineering staff is possibly the biggest challenge that broadcasters face. And I think the jury is still out on whether broadcast engineers getting to understand IP or IP network engineers and introducing them to broadcast techniques, which is the best way. I think you've got to find engineers who have a willingness to learn. And you'll find in both groups, there are those that want to learn the other technology and understand it. But what we've done with leader products, they've been designed to present IP analysis in the same format as SDI. And in their true hybrid operation mode, you can actually see the IP and SDI signals side by side. So in this example, the camera shader doesn't care if the picture's IP or SDI. All he's interested in is the picture, waveform, and vector, so he can simply and easily match the cameras. Number 6, networking redundancy and resilience. SDI redundancy was simple. We took a camera, we took an output from it. If it only had one, we put it through a distribution amplifier. We connected that to independent SDI routers, and then we brought the outputs from that, and we had 2 connections to the end device. Couldn't be simpler. 2110 systems need redundant network fabrics, and that requires both a primary and a secondary network. And these can be very simple or very complex depending how you decide to design your network architecture. But you want to make sure that the system is completely resilient. And to add to that resiliency, SMPTE has added a standard called 2022-7, Seamless Protection Switching. And here we have a sender that acts like a distribution amplifier and now sends out 2 duplicate packet streams on the red and the blue network. And then the receiving device has what we have known as a packet selection engine or a packet picker. And what that does is the first packet that arrives is accepted and is put in to the output stream. So your output stream could be 100% stream A. It could be 50% of each. It could be 100% blue. It's whatever packets arrive first. And this is also great when it comes to carrying out software upgrades to your system, because this means you can keep your system operational and carry out the software updates on the red network, bring it back up, verify that it's working, then take down the blue network. So most people, 2022-7, the real value is in allowing you to carry out software updates on your system and keeping it live. Because let's be honest, you're going to see a lot of software updates, and they are not necessarily features or benefits from an operational production side. They are security, but we'll talk about that later. And the leader products can display the path differential. So what is the timing difference between the packets arriving on the red and blue network? And we can also indicate if the content of the packets match. Because it's all well and good having stream A and stream B, but if the video content is different on them, or the audio or the ancillary data, you might as well not have it. So fortunately on the Fabrics products, on the QX series, we have the ability to tell you whether the stream matches or not, which is absolutely vital when it comes to the operation of these systems. So as you can see, the networking can be as simple or as complicated as your design requires, and you're going to need tools to monitor the health of that system, because you're going to find with IP networks, they don't typically fail by dropping off a cliff. You'll start to see trends, you'll start to see delays in packets arriving, and your engineers will learn very quickly what's known as the network signature. What's the packet inter-arrival time between a sender and a receiver? And therefore, they can identify and make the necessary corrections and adjustments to your system before it becomes a critical quality of service issue. Cost and budget management. The transition from SDI to IP does involve significant upfront costs. There's no hiding this. You've got to get IP-capable routers, switches, and edge devices. These are all going to be new to your facility. You're going to need PTP grandmasters. You're going to be moving into a world of software licenses and support contracts. You're going to need network monitoring and management tools that we've never really needed with SDI video. And the potential facility is going to have to be recabled from coax to fiber or even Cat6A+. And plus, you're going to have the ongoing network maintenance and expertise costs. So you need to be aware of these as you start planning. But don't be scared, because the benefits of IP far outweigh these initial upfront costs. Because it's going to give you a level of flexibility and scalability. Look, when we come to the router, an SDI router, you wanted to expand it. You have to buy an input module, a crosspoint module, and an output card. And if you're running a redundant facility, that's 2 of each. So that's 6 interface cards you've got to buy. If you want to expand your IP network, you buy another switch. So expansion is a lot more easier and cost effective. And with separate video, audio, and ancillary data essences, this means you can now design your networks. So say audio, you don't need to scale it to handle video. It can be done on a much smaller, compact network. You still get all the functionality that audio post-production requires, but you're not carrying the overhead of video with it like you would be in the world of SDI. And you've all heard the term of COTS, consumer off-the-shelf hardware. And we're benefiting here that this infrastructure, these products are being used by industries that are a lot bigger than the broadcast industry. Data centers are using these switch fabrics. So we can benefit from the cost and development that's going on in that much bigger industry and utilize it within the broadcast world. And it opens up the potential for cloud-based production, which is sort of the next stage, but IP opens that up to you. And it's future-proofing your facility. We're going to talk in a minute about how IP is resolution agnostic. When we went from SD to HD, we had to upgrade the routers, switches, glue infrastructure. With IP, you don't need to do that, provided you designed your network correctly. And redundancy and resilience and reliability. We can build these into the networks so that you can benefit rather than having to duplicate everything like we did in the world of SDI video. Number 8, legacy equipment integration. Many broadcasters will continue to utilize SDI infrastructure and operations for many years to come. And integrating legacy SDI and IP systems is going to require gateways, converters, and careful synchronization, and adding costs and complexity during that transition period. As I mentioned previously, leader products are designed to present IP analysis in the same style as SDI, so we can look at them side by side in a true hybrid IP operation. And also, we have devices like the LT4670 sync pulse generator, which can provide a single reference source for both your SDI, so black and burst, high-level sync, digital audio, and PTP references. Because as you transition from SDI to IP or IP to SDI, if they're not on the same timing plane, you will have quality of service issues. So having synchronization of both SDI and IP is absolutely critical. Content security. SDI is inherently isolated. As I mentioned previously, SDI is a hardware level point-to-point system. So there's no IP addressing, no packets, and no networking. If somebody disconnects a BNC connector, you lose the picture. And that makes it inherently less susceptible to hacking, spoofing, or remote interception compared to IP-based systems. Content security. As I mentioned, SDI was inherently isolated. IP is connected. Therefore, you need to consider how your IP infrastructure is going to exist within your facility. Are you going to have it so that it can be connected and visible from the outside world? If you do, you're going to need to make sure that you're implementing the correct network segmentation, firewalls, access control, encryption, and obviously threat monitoring to keep your system safe. This is something we've never really had to consider with SDI video. Number 10, monitoring and troubleshooting. Diagnosing issues in an SDI chain are mostly visual and hardware-based. We've all grown up with the picture, waveform, vector, status display, audio bars, Lissajous showing you the phase. And with the introduction of high dynamic range, we start to see tools like the CIE color chart. We've all grown up with them, we know them, we understand them. In an IP environment, we're now once again looking at that congestion, the effect that congestion has on our network. And that could be packet drop, PTP offset, multicast losses, and jitter. All of these can impact your signal, and it brings with it a new set of monitoring tools, which require advanced IP monitoring tools with telemetry dashboards and analysis systems like Wireshark, IP test sets, and software probes. But the operational workflow changes are going to allow you to go beyond the technology, as workflows often need to evolve because routing, control, and redundancy are handled completely differently in an IP infrastructure. And Leader has over 70 years of experience manufacturing products that assist broadcasters with many technology migrations. Our customers have gone from analog to digital, SDI to HD, and now UHD in many cases, standard dynamic range to high dynamic range, and now SDI to IP. And where a broadcaster, like yourselves, may migrate a facility once in your lifetime from SDI to IP, Leader involved in multiple customer migration projects. And as I mentioned earlier, we're frequently the referees when sender A can't be seen on receiver B. And does the issue lie with switch manufacturer C? This knowledge and expertise we can share with you. We also have a wealth of information available online via our YouTube channel, where we have not only product videos, but we also talk about test and measurement techniques that are evolving and being deployed within this new SMPTE 2110 world. And we also have audio podcasts that are available to download. And we have our after sales and support on our website, www.leaderfabrics.com. And here you can find how to contact us should you have any support issues, quick start guides, manuals, frequently asked questions, software downloads, product warranty registrations, all the information that you might need on a day-to-day basis is in a single, easy to access website page. So as I said, these are the top 10 challenges when it comes to migrating from SDI to IP. And at Leader, not only are we a product manufacturer with a comprehensive range of reference generators and analysis and monitoring tools, but we're also able to share our personal expertise with you when it comes to your migration. So despite the challenges, SMPTE 2110 offers you tremendous flexibility, starting with routing video, audio, and ancillary data separately. And the scalability. This now allows you to build the system to satisfy your operational and production requirements today, knowing that it can be easily expanded in the future. It's video resolution agnostic. We've seen rapid changes over the last decade of going from SD to HD to UHD. All of those have required hardware to be changed. In the world of IP, that's not going to be the case. Remote production. We're now starting to see more and more broadcasters use remote production. So rather than having huge production teams at remote venues, let's bring the signals back. Let's use the tools in a production environment they're familiar with. Virtualization. We're seeing more and more of this now, and the adoption of 2110 is a gateway to do this. And cloud integration, which is the next logical step for broadcasters. And Leader can be your trusted test and measurement partner throughout your migration. If you have any questions, please don't hesitate to contact me on the numbers currently on the screen. As I said, we're not just an equipment manufacturer. At Leader, we have a vast wealth of experience of migrating customers to the latest technology, and we can share that with you along with leading state-of-the-art test and measurement tools that can guarantee your facility runs seamlessly and delivers the high-quality programming that your clients and customers expect.